Yeah, thank you. I'm Ben Tovar. I work at the University of Notre Dame. And today I wanted to talk about some of the ideas we have been researching about resource management with the Coffea framework, specifically with the Work Queue executor. So I assume that most of you are familiar with Coffea. If you are not, I think this is going to be a very boring talk. But if you don't, Coffea is a prototype for pulling together many different tools for a HEPA analysis. And the idea is that you write processing and analysis functions, accumulating functions, and then those get executed somewhere. Where things get executed is the task of executor. So there is like the task executor and Spark. And in this talk, I'm going to focus on the Work Queue executor. The Work Queue is a library to create scalable manager worker style programs to scale into thousands of machines and clusters. The idea that to use Work Queue and Coffea is to send whatever work you need to do to remote clusters, either by themselves or in some container environment. Two of the advantages that Work Queue has when used together with Coffea is, as I said, the resource management. And the other is, if you cannot pre-configure where the functions are going to run, Work Queue has some tools to do that. So you don't need to pre-configure where functions are going to run. The picture that you should have in mind is that you have Coffea running on top of the Work Queue executor, and they talk to remote workers, which run either locally or in clusters or in grids or in the cloud. By talking to those workers, they send the processing, accumulating, and all the functions that you need to run, and then they send the results back. And that's the most basic architecture that we have. In terms of installation, if you're following this from Binder, you should be set already. The only ugly thing that happens is that in order to make the examples interesting, I wanted to show you how you can run different functions at the same time using a single worker. That seems to make my Binder unhappy just because of the limited resources that it has. One way to fix that, or try to fix that, is to let Work Queue know the limits of my binder. So in this case, we'll read the CPU limit and memory limit that binder is giving us. In general, you don't have to do this. The workers know how to do to automatically configure themselves. The only problem in binder is that the apparent resources are not the resources that you are actually allowed to use. So this is the code that you see here. You don't need to do this, for example, if you're using Google Colab or directly in the shell from a Conda environment. So with that, let's go to the demo. The three things that you almost always need to import is the runner from Coffea, the Work Queue executor, and then a factory that will create the workers for Work Queue. And then for the purposes of this demo, I'm going to use the pretty basic processor in the testing items that Coffea has. So that's this will be the part of the analysis that you will write, for example, to match whatever you want to do. And then I'm going to use, we need to define which data we're going to run. And in this case, I'm just going to use a single file to make things fast and easy. In the demo I have in Binder, this file comes from HTTP. I copy it locally just in case something goes wrong. Now, the most basic configuration that you need to do for Coffea and Work Queue together is that you have to, saying nothing else, you have to define which port Work Queue is going to listen to for workers to connect. Later, we are going to see how this port can be configured automatically. But for the most basic setup, you define a port, you tell Work Queue which port is going to run, and then you define the runner for Coffea using the executor that we defined. And that's all you need. The other thing that we need is to define our workers. And for that, I'm going to use the Work Queue factory. The factory allows you to define workers, and it creates workers as it sees work from the runner in Coffea. In this case, you're going to run the workers locally. But say if you're in a batch system, you can change this to use Condor or SGE and so forth. And then the factory will create the workers in that batch system. The other thing we need to say to the factory is where our manager is running, in this case, locally at a certain port. I'm also setting a limit on the maximum number of workers that I want. And finally, the last thing that you need to define usually is the resources of your workers. Say if I'm running for Condor, the resources that I define here will go to the submit file. So the workers will be created with the resources, or will be scheduled in Condor with the resources that you define here. Since we are doing these things locally, Work Queue just trusts that you know what you're doing. And if you override any values here, it will think that the worker has those values. So in this case, I'm just defining that I want my workers to have one core in order to be able to execute one chunk at a time. So I define my factory. And finally, we use context to run our executor, our runner of Coffea inside the factory object. So I give it our input files, the tree we are going to process, and then the processor that we define the testing. And one thing that you will see in this example, or you will want to pay attention to, is how the largest scene worker, that is the only worker that we connect, all its resources are going to be given to the tasks. So the current allocation that you will see. So if I run that, we see a bunch of statistics. Eventually, a worker will connect, and we will see this largest worker, as you see here now, with one core and some memory and some disk. All these resources get assigned to a task, so current allocation. And the same happens for processing and accumulating, pre-processing, and processing functions. Now, one thing you will notice is that Work Queue automatically measured our tasks. So even though, for example, for processing tasks, we say we allocated one core and 16 gigabytes of memory, really Work Queue is telling us like we are way off in our memory, right? Like these particular functions use less than half a gigabyte. So that's interesting information. That tells us that maybe we can run more functions at the same time. And to show you that, I'm going to manually declare the resources that each task uses. So the first thing I add is to change the executor definition to say all of my tasks are going to use at most one core. And I'm going to cheat a little bit and say that my local workers actually have two cores. So with that, we will expect to have two functions running at the same time per worker. And you'll see, again, once the worker connects, that the largest worker says that it has two cores and 16 gigabytes of memory, but each task gets assigned one core because we said that our tasks use maximum one core. And then all the resources that we didn't specify get proportionally divided. So we had 16 gigabytes of the worker. So now each task that we didn't specify gets 8 gigabytes of memory and 5 gigabytes of disk. And this happens automatically. And what else I wanted to show you here? I think that's it. Yeah. Now, of course, this works, but it's a little annoying because you don't usually know a priori the resources that your tasks are going to use. So something that Work Queue has automatically is that if you don't say anything, Work Queue will adapt the resource allocation according to the measurements that it sees on the tasks. And this happens automatically. The only thing that it didn't happen in our example here is that I'm only using one data file. So we created very little tasks for Work Queue to gather data. So what I'm going to do is to run the same example. Now I don't specify any resources for my tasks, but I reduce the number of events per task. And this is just a trick to create more tasks. So Work Queue has data to make it computation. You will see that at the start, each task gets allocated the whole worker, that is 2 cores and all the memory. But as tasks come back, Work Queue realizes, oh, this is too much for this task. And then eventually it will be able to run 2 tasks at the same time. So if I run that, we wait for the worker to connect. We see that the worker connects with 2 cores. So far, Work Queue has seen the largest task uses 1 core. Originally assigns 2 cores for all of the tasks. So we are running only 1 task concurrently, but eventually it realizes that, oh, this is way too much. So automatically it reduces the allocation to the task to 1 core and to 8 gigabytes. And this is done proportionally according to the maximum values that we see. I think the minimum task number is 5 or 3 or 5, I don't remember. And that's why you see that, for example, for accumulation tasks, Work Queue didn't have enough information to make a more educated guess about the resource allocation. There are other resource management modes that you can use. One thing, for example, is that if you specify maximum resources for your tasks, the automatic resource allocation still works, but it takes the values that you declare here as the maximum any task can use. And if a task goes above those values, then something happened that I will explain later. The other thing you can change is that for processing tasks, we take the maximum resource value seen for our allocations. We have seen this works really well for all the Coffea workflows that we have tried, but it might be that some tasks are just outliers. And in such cases, you may want to change the resource mode to max throughput. And in this case, the allocation is not based on the maximum, but in some optimization where some of the outliers get retried using full workers, but all the rest of the tasks use less of the maximum that we have seen. And finally, of course, something you can do is to say, don't do any computation, just use the resources that I tell you, in which case you will use the resources mode fixed. And it might be that you only want Work Queue to account for your resources, but not to measure them, in which case you can also turn the monitor off. One thing that often happens with especially when you're trying new Coffea workflows, is that the tasks are way too big for the resources that you have. This might be a combination that your processor really uses more memory than you thought, or maybe the chunk size that you choose, that is the number of events per task that you have chosen, is way too big, and then the task won't work. If you specify resources like that, like a maximum task resource, for example, like 60 gigabytes of memory, and no connected worker has that much memory, then Work Queue will just wait. It will tell you, I can't run this task, and it will wait for larger workers to connect. And the same thing happens if you don't specify anything, but during runtime, we realize that some task is using more resources than the available workers. It does the same, it just waits and it tells you that I need a larger worker. So either terminate me or feed me another worker larger. And an example of how that can happen is, for example, I declare my worker with only 4 gigabytes of memory, but I say that my tasks use 8 gigabytes, then that's not going to work. If I run this in the notebook, this actually will block because how I set the factory here. So worker will just wait for a new worker, but then the cell never terminates. And the way to go around that is that you can feed a worker outside a notebook, and we will see that shortly. Now, there are 2 things that happen when a task is too big or too large for the allocations that you specified explicitly. For preprocessing and, for preprocessing and accumulation tasks, they just fail permanently because there is no way we can modify those tasks so that they run with the resources that were explicitly stated. However, what we can do for processing tasks is we can modify the chunk size dynamically, and that's what we do with the Work Queue executor. And I must tell you that from this point on, if you've been following in my binder, some of the examples may not fit in memory now, so it may cause your notebook to disconnect. And I tried really hard to find values that work in my binder, but then they were not very interesting. So if you want to follow this, you can either do it locally or in Google Colab. So one thing that Work Queue does when a processing task is too big, that means it has way too many events in it, is that it will see that it didn't fit, and then it will split it and then retry the parts and then keep doing this splitting until either it cannot be split anymore or we reach a maximum, which I think the default is 5. Yeah, the default is 5. Now, for these examples, I'm going to use a slightly modified basic test processor, which the only thing it does is to increase artificially the memory that the task use. And this is just for show. So I'm going to read our new processor. One thing that now we have to do is that since the processor I'm using, the source of that processor is not part of the Coffea distribution, we have to tell Work Queue that it needs to send this source file together with the tasks. So we do that here in this Work Queue executor parameter, where we just give a list of extra source files that need to be sent. For single file processors, as in this case, or accumulators or things, or small data, things like that, this works really well. If you need to do more, like a more complicated environment, I will show you how Work Queue can do that too, like send complete conda environments. And the other thing I'm doing here in this example is setting a chunk size big and a memory like ridiculously low so that the tasks fail. And as the tasks fail, they are going to be split, and then we will observe the change in the chunk size as the example runs. Also, I set my workers so that at most 2 tasks run concurrently once we find the correct chunk size. So we will see that some of my tasks are running. I start to get errors because they don't fit in the resources that we specified. Eventually, you will see this counter to go up because they didn't fit. We will see, right, so at least 2 tasks have been exhausted. That means that 2 chunks of events have been splitted. And after the split, the minimum chunk size that we have seen is this value. Now, usually if you see this kind of behavior is that probably you want to rerun your workflow with a new chunk size. So this is great for exploring what are good chunk size given the resources that you have. It's also a lifesaver if only like a handful of tasks need splitting, then this will make the whole run work for you. But again, it's not like the most efficient way of running. The other thing we can do is rather than wait for things to fail, is that we can tell, and then you get a bunch of debug information in case you want to see which task failed. But one thing we can do is, rather than have a fixed chunk size, we can tell the work queue executor a target resource utilization that we want, and then we can let work queue find a chunk size that will fit that resource without going over. So in this case, I set a small number of events per task initially. I said that I want each of the tasks, processing tasks, not to use more than ½ GB. And then I tell Coffea, please adapt my chunk size to fit that target memory. So what you want to pay attention in this next example is how the current chunk size goes up. The maximum memory sink also goes up to fit the target that we set. So we wait for the worker to connect. And as you see, we are submitting tasks very slowly because my current chunk size is very small. Eventually, work is going to realize that that chunk size is too small, and then it increases it. In this case to 32K. And eventually, the largest scene memory will be close to the 500 megabytes that we set.
Ben, I know that you only have 2 more segments in the notebook, but I think we should probably try and be wrapping up so that we can still make sure that we have time for a break.
Oh, great. Excellent. Yeah. So, right. So let me, yeah. So as you see, probably you also don't want to use this dynamic mode all the time, but it's great for exploring your new processors and new resources. And then once you find a chunk size that works, you want to set that forever, at least for the rest of the runs. So in the interest of time, let me switch ovens, so to speak. So let me. One of the things that we have been doing so far is setting the port in a fixed way, and that's kind of not very scalable. So one thing you can do with Work Queue is to give the Coffea run a name. That name and the port is running gets registered in a catalog, and you can run your own catalog server, or you can use the one that we run all the time at Notre Dame. And then workers can connect to that catalog, get the name, and then connect to the manager. To do that, we usually recommend to set a password that gets shared between the Work Queue executor and the workers. So as you see, it's just a matter of giving a name, the password, and everything else remains the same. The other thing is the factory now needs to know the name of your manager. And the other thing I wanted to show you is, so I show you how to send a single processor file with the tasks. But sometimes you want to have the full environment, so you cannot install Coffea at the execution site. Together with Work Queue, we have a tool called Poncho Package Create, to which you define a specification, which is actually the same as a Conda specification. We write that to a JSON file, and then we can feed that specification to our tool, which then creates a tarball that we can send together with the tasks. And this tarball gets sent and expanded only once per worker, so it's efficient. And one thing I'm going to skip, but just so you know that, I mean, of course we can do, is to run the factory outside the notebook so that you can have your manager running in one machine and the factory running in a front end on an HPC, for example. And I think that's all I have. So if you have any questions, I'd be happy to answer them.
Okay, great. Thanks very much for the nice talk. I think in the interest of time, we're going to just take one question now, and then we'll go to break and we can migrate everything else. So let's take Nikolai's question of how does Work Queue compare to Dask?
So one thing that in terms of the executor is that for Coffee, we are more, I think we are more integrated with Coffee, in the sense that we are more dynamic in the way we are creating the tasks. Right now, how the Dask executor works is that Coffee gives the whole graph of tasks to execute to Dask, and then they get executed. And that's just a matter of how the executors are implemented right now. Like, I don't think there is no stopping, modifying the task executor so that it can do all these things that we are exploring with Work Queue right now.
Okay, great.
Yeah. And just to answer Oksana very fast. Yeah, so actually here at Notre Dame, the CMS group uses always the Work Queue executor. So I don't have the numbers right now, but it's in production here right now.
Thanks again, Ben, for this super nice talk.